Particulate live session. Hello everyone. How are you doing? Yes, everyone is waving their hands. Hello. Are you ready to attend the class? Give me a thumbs up so that I can move forward. Yes, everyone is giving their beautiful thumbs up. So let's start the class with a beautiful smile on your faces. Can I get a beautiful smile from your faces? Yes. How beautiful, right, ma'am?
Yes.
Yes. So, as you know, this is a live YouTube session. You know that, right? And we have started a new YouTube channel called the 90 Plus Middle East. So you can just subscribe the channel, and also the most important thing, you have the link with you, right? You are provided with the link. Just share it with your friends and in your network so that they might get an information that we are going and YouTube live over here. So let's study together, right? So will you do that? Will you share the link with your friends?
Yes.
Definitely yes, ma'am. We'll do that. Right. Very good. Very good. So do that. Meanwhile, let me talk about the chapter that we are going to discuss. Can you have a guess? Which is our first chapter that we are going to study? Which is the first chapter from your syllabus? Let me know how many of you have opened the notebook really. Yes. Let me know in the comment box which is the first chapter that you have. Very good, very good.
Our surroundings.
Just nothing but very good. Our matter in our surroundings, which is nothing but our first chapter. You know that, right? Before moving to the chapter, the first thing that you must have is your notebook. You must have a notebook, a pen, and a highlighter so that you can note down every point. Do you have the notebook? Let me check that. Let me check that.
You please raise your notebooks.
Yes, sir. Very good, very good. So, for your kind knowledge, we have our supporting tutor over here. The ma'am is here and she will help you with your doubts. Okay, you can just, Arya ma'am is here, you can just note down or you can drop your comments over there. She will get you from the doubts. Okay, yes, and we have Sibin sir over here as the host. He will also support you guys. Okay. Here we go with the first chapter, matter in our surroundings. So again, before moving to the chapter, we will do a lot of experiments. Live experiments. So you are also going to do with me, along with me, okay? So all you want is a glass of water or just a glass and a bottle of water and a spoon and also sugar or salt as you wish. Will you get it now? Did you got it? What are the things that you need? A glass, a bottle of water, spoon, sugar or salt. So quickly grab it and come back. Quick, quick, quick. Everyone, go and grab glass, a bottle of water, spoon, sugar and salt. We are going to do a lot and a lot of experiments. Okay? We have to make our session live, right? Yes, so let's do that. Everyone, quick. Everyone must do the experiments.
Teacher, will you please again repeat it?
Yes, we want a glass, a bottle of water, a spoon, sugar or salt.
Okay.
Is that clear now?
Yes.
Very good. Quickly go and grab it. Everyone must have it, okay? Because everyone is doing the experiment along with me. And along with the animations, we also have the beautiful animations. Give me a thumbs up if you're done with that. Give me a thumbs up. Give me a thumbs up, everyone.
Most of them.
Most of them came back. Yes, I'm waiting, and I'll wait for one more minute. No worries. Done? Very good. Give me a thumbs up. Give me a thumbs up if you're done with that. A double thumbs up. A A double thumbs up. Very good, very good. So here we are with the first chapter, matter in our surroundings. So in the previous session, we detailedly discussed about what a matter is. Am I right? Am I right? Very good. Now who is going to tell me what a matter exactly is?
Yes. Let's ask Sanjit.
Sanjit, yes, Sanjit. Can you please unmute?
Yes, ma'am.
Hello Sanjit, how are you doing?
Hello. Fine, ma'am. Matter is anything that has mass
Uh,
and occupies space is called matter.
Yes, very good. Matter is anything that has mass and occupies space. That is exactly called as a matter. Now let's move forward. Here we have our bedroom, which consisting of lot of things with the different materials, different shapes, different sizes, right? We have a lot of things around us. You can notice that, right? And we have discussed that in the previous class too. Here we go. What are the things that you can see around? What are the things that you can see around in this picture? Let me know in the comment box. Let me know in the comment box. What are the things that you can see around here? It's a New York City, a busy day. And what are the things that you can see right here?
Yes, we have comments like buildings, cycles,
Buildings,
papers, cars. Yeah.
Very good. So there are so many things around us, so many substances, right? And the scientist concluded that all these substances are nothing but a matter. Everything around us, the stones, the clouds, the air we breathe, the food we eat, the water we drink, everything around us is nothing but a matter itself. This was so clear for you guys, right? Yes, here we go. The football, the phone that you're using right now, and the books that you're studying, and the pen, water, and here we go, the plants and the food items. Everything, literally everything in the universe comes under the classification matter. So matter is everything. Matter is everything, as we know that, right? Yes, very good, very good. Now, a big question. What is matter exactly? What is matter exactly? As he said before, matter is nothing but that has mass and occupies space. Here we have the beautiful definition for the matter. Matter is anything that has a particular mass and occupies space is called as a matter. So what is matter? You have to by heart this right now. No by hearting in our class. You have to understand the concepts. You have to understand the concept. What is the concept over here? Matter is anything that has a particular mass and which occupies space is called as matter. Let's take an example. I have the pen right here, right? I am holding a pen over here. And this pen has certain mass. And this has certain mass. And this pen is exactly occupying some space over here. And this pen is matter. And I'm talking about myself. I have certain mass and I'm occupying some space over here. So myself, I am a matter. You guys, everything is just matter. So what is matter? Yes, ma'am. Unmute someone and let's ask.
Okay, let's
what is
ask,
matter?
Daniel Joshua.
Daniel, what is matter?
So, teacher, matter is anything that has mass and occupies space.
That has mass and occupies space is nothing but a matter. Now, let's do an experiment, okay?
Teacher, we have a camera of Shreya Shaji. Can you please?
Is that true?
Yes.
So, why is that camera off? Can you please unmute her? I had told you in the beginning class itself, we don't allow the camera offs in our class. It's very mandatory that you have to turn on the camera. Yes. Did she turn it on?
Yes, I think.
She will soon.
Yeah.
So let's continue. Now I have a glass. You can see that, right? I have a glass over here. You all have the glass with you, right? Yes, don't take it now. So here, I have the glass And I have the water bottle and water in it. So I am filling this water over here. Can you see? My water is just filling in the glass and it is filled. You can see that, right? My water is just filled in this glass. So water over here is taking up the space of this glass. Am I right? The water is taking up the space inside this glass. Am I right? Yes or no? Give me the answer. Yes or no? Definitely yes. The water is taking the space inside this glass, as you can see. So what happens if I keep on pouring the water inside the glass? What happens if I keep on pouring over there? What happens? It will overflow. It will overflow, right? And I will never do that because our Cbse sir over here will kick me out if I do that. Okay, so I will never do that. I will not overflow this glass. And that's what I am explaining right now. They are occupying some space inside this glass. And if I weigh this, it has certain mass. It has certain mass and I can call this water as a matter because the water is taking up the space inside this glass. Am I right? Yes. Now we have talked about the pen and the water. Pen was nothing but the solid and the liquid. The water was nothing but the liquid. And what about the air? I'm sorry, wait for a second. Yes, what about the air? How do we know air or any gas really is there if you can't say it? Can you see the air around you? Can you see something is floating over there in front of your eyes? Never, right? You cannot say it. You cannot say it, you cannot feel it, you cannot feel where the air is. But how do we really know air is there at that point? How do we know that? That is why we will move on to the experiment. Again, we have the experiment. What do we have right here? What do we have right here?
Yes, balloon.
Yes, very good. We have the balloon. We have the balloon. I know you will not be having a balloon right now with you. So I'll just do the experiment, okay? Just watch me. I have the balloon over here. So let's check whether air is really there or not, okay? So I am just blowing this balloon up. Shall we do it? Shall we do it? Give me a thumbs up. Everyone is laughing over there.
Yes, everyone
They are
is
so
very much
excited.
interested,
How
yes.
am I going to blow this balloon?
Yeah.
Yes, so let's do it, okay? I have the balloon over here. So let's just fill it. Watch me. Actually, it's not filling up. Let's do it again. Here we go. Here we go. So the balloon is just blown. So what does this balloon contain now? What is inside this balloon? What is inside this balloon?
Yes, air.
Definitely, air is there. So it is the experimental proof that air is there, air exists. Okay, so air is there inside this balloon so that it just filled. So they takes up the space inside this balloon. They just takes up the space inside this balloon. Am I right? Here we go. Is air a matter? Next question. Is air a matter? Is air inside this balloon a matter or not?
Yes, ma'am.
Definitely it's a matter. Why? Why? Let's unmute someone, ma'am. Why the air inside this balloon is called as a matter? We cannot see it, but how come it's a matter?
Let's ask Hriday.
Hriday. Yes, Hriday. Tell me, how does this air inside this
Ma'am,
balloon a
it's
matter?
occupying space.
Yes.
Definitely. Definitely yes. Definitely yes. The air inside this balloon is occupying the space inside this particular balloon. Hence, the matter, the air is a matter. The air around over here is a matter. Air is a matter. Now, what about mass? What about mass? I'm just removing the air over here. I just removed it, okay? So, sir, can I get the balloon? Sir,
Okay.
there. Here. Here we have the blonde balloon, the balloon full of air. And what do you think? This balloon or this balloon? Which will weigh more? What do you think? What do you think? Which balloon will weigh more? The empty one or the full one? Yes. Which one will weigh more? What do you think? The empty one or the full one?
Some are saying empty one, some are saying blown balloon.
Blown balloon. Some are saying the empty balloon is heavier than the full balloon. Let's unmute and ask.
Okay, let's ask. We have a lot of hand raisers and just let's hand raise some of them.
Yes.
Haifa.
Haifa. Yes, Haifa. Tell me, which balloon will weigh more? The blown balloon will weigh more. So I will not trust that. I will not trust that. So we'll conduct another experiment, say the animation. Let's play an animation, okay? Let's play an animation. Let's check out whether this balloon weigh more or not. Let's check it. Yes, sir. Here we go. Here we have the balance thing, and let's plug one unblown balloon in the one end, and in the other end we have the full balloon. And what did you observe over here? What did you observe? In this particular animation, what did you observe? Yes. You can play that again, sir. What did you observe? Let's unmute someone, ma'am.
Okay, let's ask Sharon.
Sharon, what did you observe over here?
The balloon.
Yes, Sharon, come on. Sharon?
Yes, ma'am.
What did you observe over here in this particular animation? What did you observe?
The balloon which has air in it, one which was blown, weighs more.
Yes, the balloon at this end, which is the full balloon, which is full of air, weighed more, and it's just sinked down, right? It just sinked down, as this balloon will be having more heavier than the empty one. What is the conclusion now? What is the conclusion? The blown air will be having more weight than the empty balloon. So always remember, the full balloon, the balloon which is filled with air, will have more mass than the empty balloon. So what does this really indicates? What does this really indicates? Tell me, what does this really indicates? It indicates that our air is a matter. So you can remove the animation over there. That is, air is nothing but a matter. Air, the balloon, the air that is inside the balloon is taking up the space inside the balloon, and which is heavier than the empty balloon. That means it has certain mass. So the conclusion is, air is a matter. Air is a matter which will be having mass, and they occupies some space. So that's it. That's all we want to know. So air is a matter. So everything around us is just a matter. The solids, liquids, and the gases. No matter what, everything is just the matter. Everything is just the matter. So that's it. Now what are we going to discuss now? What do you think? What do you think are we going to discuss now? Who are these? Who are these people? Who are these people? Can you have a guess? Who are these people? Definitely they are humans. Someone is giving me like they are humans, ma'am. Definitely yes, they are the humans. And
Priest,
you have to imagine that
Guru and their students.
he is an Indian philosopher. Okay.
Yes, Indian philosopher.
He is an Indian philosopher, and here we have more Indian philosophers. They are just listening to their speech. So they are the Indian philosophers. Now what are they doing over there? What are they doing over there?
Zuhair observed that God have two heads.
All right. The God have two heads over there. They might be an identical twin, right? So here we go. As we are discussing about the matter, they are also discussing about the matter. They are hardly discussing about the matter. And what are they thinking right now? They said that the matter can be classified into 5 basic elements. They said that the matter can be classified into what? Classified into 5 basic elements. And which are the 5 basic elements? Which are those 5 basic elements? Which are those 5 basic elements? Someone is laughing over there.
That's me.
All right.
Okay.
Yeah, tell me, which are
Air,
the 5
water,
basic elements
earth.
and what do we call that 5 basic elements as?
Yes, we have a lot of answers, lot of hand raises.
Yes, keep doing that. I'm so much happy that you're answering everything. Very good.
Okay, let's call someone.
We have listeners in a YouTube channel also. Yes.
Okay, Fatima. Yes, Fatima.
Yes, Fatima.
There are 5 basic elements: water, earth, fire, sky, and water.
That's it. What are those 5 elements called as?
Not only know some. Air is Vayu, and fire is Agni, sky is Agash.
All right. Very good, very good. Sir, can we have the animation? The 5 elements. 5 elements. Let's watch the animation. Okay, what are the 5 elements do we have? The first one is air. The first one is air. Second one, earth. And the third one, fire. And the fourth one, sky. And the fifth one is nothing but water. Again, air, earth. Then, what do we have? Fire and sky. And the last one, water. And what are these 5 elements called as? You can remove it, sir. What are these 5 elements called as? The first one is air or Vayu, as she said. Okay, it is the Hindi term Vayu. Vayu is nothing but air. And we have the earth over there, which is nothing but Prithvi. And we have Jal, which is nothing but water. And we have Agni, which is fire. And finally, sky or the Akash. And we call these 5 basic elements as Panch Tattva. So what is Panch Tattva? These 5 basic elements are called as the Panch Tattva. Air, earth, water, fire and sky. Vayu, Prithvi, Jal, what is this? Agni and Agash. So these 5 elements are called as Panch Tattva. Panch is nothing but 5. Tattva means elements. That means 5 elements. And also the thing has to be noted is earlier Indian philosophers thought that everything, all the living and non-living things are made up of these 5 elements. Okay, they thought that all the living and non-living things were made up of these 5 elements. Okay, so this is called as the Panchatattva. And the hand rises are over there. Do you have any doubts?
I think they are hand raised to answer.
If anyone have any doubts, you can just stop me at any point that you want. You can just raise your hand, ask me questions directly. I will clarify your doubts. Okay, no worries. Okay, I'll be very happy to answer for you guys. So you can just raise your hand to ask any questions. So if you don't want to ask me directly, here we have the supporting teacher Arya ma'am is over here. She will help you with that. If you just drop your doubts in the comment box. Okay, that's it. Yes.
Mohammed Maz has a
Mars. Yes, Mars. Mars want to know about acid rain, I guess. We are not talking about acid rain over here, Mars. Yes.
Yeah. So, as you explained like in the before slide, you said that can you see air? But actually you can see air.
Yeah.
The first one, right? It's a symbolic representation.
No. Yeah, he
Because
already
this
told
one,
that
that's
in the
like
box.
the I don't know, like second and third slide after the starting chapter. Two more
Which one?
The 8th slide.
8th slide here.
It's like how do you know air or like any gas? Can we really see it? You can actually see air.
Can you see the air around you?
2 winds maybe.
No, like what we currently, not currently, you can see like if you have like a big mirror in front of you, if you like exhale your like like you do something like half like in front of the mirror.
Last time.
Oh,
Like,
that is
the
nothing
air,
but the
how do-
That is not air. That is the water vapors that you are blowing right out. So that is not the air. Okay.
No, like then the air like reflects back, and then you can see that the air like reflecting back.
Actually, I didn't mean that. Okay, the air around us. The air around us. Can you see that? Can you see hydrogen and oxygen and nitrogen floating over there?
You can see the air in the body.
Air in the body?
Yeah.
I think you have the superpowers.
No, like when you remove it.
Do you have to
When you
remove?
cough
Do you have to remove my body? And you can see the air.
Okay, teacher.
No, actually you can see air around you. Yeah, it's
Around
more
me?
like I mean,
Mas, what are
No,
you talking about?
no, I'm telling if you go like if you're going on a trip like, in a plane around you, like if you see outside, you see all fog and air. So that's also.
Those are the clouds. Those are the clouds, not the air.
No, ma'am, around the glass like full air, fog, right? So it's like it's
That
not
is
just air.
that is called as condensation. Air particles will condense into water vapors. We'll study detail in the
We
upcoming
only said
classes.
air
Okay.
particles.
So it is sure that air particles is there, but we cannot see it. The air is there, but we cannot see it. Mass? That's it. We cannot see the air. That's why we have blown the balloon to check whether air is there or not. We found out that air is there really. Now here we go. Panch Tattva is over. Panch Tattva is over. Now, later on, as the time passes, scientists found that matter is consisting of not these 5 elements, but they classified matter into 3 basic states. 3 basic states. Which are those? Which are those? The 3 basic states. Actually, we have 5. We are not going to talk about other 2 right now. The 3 basic states. Which are those? Very good, children. Very good. You all know the answer. Which is nothing but, shall we unmute someone and ask, ma'am? That's a better thing, right?
Okay, we have a lot of hand raises.
We have
Let's
a
ask,
lot of hand raises.
Alfie.
Alfie. Which are those 3
Solid.
states?
Solid, liquid, gas.
Solid, liquid and gas. Very good. Here we go. The first one is nothing but solid, and the second one a liquid, and the third one gas. So solid, liquid and gas are the 3 major states of matter. So all the matter exists as these 3 states. All the matter around us, whether it's a living thing or non-living things, based on the physical properties of the matter. Based on what? Based on the physical properties of matter, the matter is classified into 3 basic states: solid, liquid and gas. Is this much clear for everyone? Clear so far? Give me a thumbs up. Give me a thumbs up if this much clear for you. So now you have an idea that what a matter is, what are the 3 states of matter. Everything is clear, right? Let's unmute someone, ma'am, and let's ask what are the examples that you can give for these 3 states.
Let's ask Ishan.
Ishan.
I just wanted to say that there was 5 actually, right?
Yes,
There are
there
five
are
states
5 states, but we are not going to talk about that 2 states right now, but later on we'll study that.
Okay.
Which is nothing but plasma and Bose-Einstein condensate.
And
We'll
both
study
are
about that.
condensate.
Very good. We'll study about that. Now, the only thing that you have to study in this particular chapter is nothing but solid, liquid and gas. Okay?
Okay, ma'am.
So, can you mention 1 or 2 examples for 3 of them?
Mommy?
Money is an example for solid. Very good. Very good. Then, what is the example that you can give for liquid?
Water for liquid.
Then,
Air for gas.
which air? Air consists of so many gases, right? List out 1 or 2.
Air, ma'am.
Air around us will be having so many gases. Name out 1 or 2 gases around there.
Nitrogen.
Nitrogen, very good, which is the most abundant gas found in the nature. Nitrogen, very good. So you know exactly what are the states of matter and what are the examples that you can give for the matter. Am I right? Am I right? Very good, very good. Now let's move forward. Again, a big question. What is a matter made of? Again, are you taking down everything? Or just watching like sitting like watching movie?
No, ma'am.
No, ma'am, we'll never do
Most
that.
of-
We are writing down everything.
I
You can
think
see that.
Sanjit has any doubt?
Sanjit,
Yes.
Sanjit, do you have any doubt?
I had that one. No, ma'am, I wanted to answer this one.
You want to answer this question? This was a big question that I am asking right now. So you want to answer it? Very good. Do it.
Okay. The matter is made up of tiny particles called atoms and molecules.
Yes, that's it. He's like, was this a big question, ma'am? It is the simplest and simplest question that I've ever had. Right, Sanjit? Yes. Alright, so we have to study what exactly this matter made of. We have to study it, right? Here we go. The physical nature of a matter. As Sanjit said, every matter is consisting of tiny, tiny particles, and we can call that tiny particles as atoms and molecules. We will study detailedly about what an atom is and what a molecule is. We'll detailedly study about that. Okay, we will study that. Now understand that everything is made up of, even me, the pen, everything around us is made up of tiny, tiny particles. They are very tiny. You can't see them with the naked eyes. You cannot see them. They are very tiny, beyond your imagination. Beyond your imagination, it is very much smaller. So always remember, what are particles? Particles are the building blocks of the matter. So the matter consists of these tiny, tiny particles. Always keep this in mind, okay? So if you have a wall around you, you have the walls around you, right? Yes, you have the walls around you, which consists of so many bricks. Am I right? The wall is consisting of so many bricks, and one brick is called as one particle. And like that, the particle constitute an entire matter. So taking this pen itself, this pen will be consisting of millions and millions and millions of particles. You can't even imagine that. So here we have a statement. 1 grain of salt has 1.2 into 10 raised to 18 atoms in it. Can you imagine that? Can you imagine that? I will get you an idea about that. First of all, take down this definition. First of all, take down this definition and I will clarify that.
Yeah, we have doubt like what is matter made up of? Can you repeat please? Like that.
Yes, a matter. So everything around us is just a matter. And everything is made up of tiny, tiny particles. Okay, everything is made up of tiny, tiny particles. And these particles, we can call them as atoms and molecules. Atoms and molecules. Particles are nothing but atoms and molecules. These atoms and molecules are very much beyond our imagination. It is very much smaller and tiny in nature. They are very much smaller. So imagine 1 grain of salt. Okay, you have the salt and sugar with you, right? I told you to grab it in the beginning itself. You have the grain of salt and sugar. Just take out 1 grain out of there. Just take out 1 grain.
Yes, Daniel have a bottle of sugar.
Huh?
Yes, they all have
They all.
a bottle of sugar.
Yes,
salt,
they
whatever.
have a bottle of sugar. I also have a bottle of sugar. So just take out 1 grain. 1 grain of sugar. Someone is showing there
Yeah,
to
Neha
the
is showing.
camera.
Yes.
1 grain. I only want 1 grain, okay? Take out 1 little grain from the salt or the sugar that you are grabbing right now. Can you hold it?
Most of them are doing, but some of
They
them
are-
not doing.
Some of them are not doing.
No.
Why? This is a chemistry class, right? You have to do the experiments. We want the experimental proof for everything. It's not like we'll believe everything as you say. It's not like that. We want the experimental proof, right? So you have to do it. Everyone have the 1 grain of salt or sugar with you, right? And do you know how much atom that 1 grain contains? Here we go. It is, here we go. Yes, we have so much sugar with us, but 1 grain, the 1 grain of sugar, let me change the color of the pen. This little 1 grain will be having 1 followed by 18 zeros. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. This much particle in it. So the grain that you're holding right now, you have the grain, right? The grain that you're holding right now will be having this much particle in it. This much particle in it. Can you even imagine that? You will not be having that much particles inside your bottle. Okay, you will not be having this much atoms or the particles in your bottle itself. You will not be having it. So someone is counting that. Don't do that, okay? Don't count the number of grains in your glass jar. Don't do that. So just imagine 1 grain. Even little 1 grain of sugar will be having this much atoms in it. That's nothing but 1 into 10 raised to 18 particles. 1 into 10 raised to 18 particles in it. Can you imagine that? I can't. So the particle will be consisting of these much atoms. Can you count this? Can you? Anyone in the class? I'm challenging you. Can you count this? 1 followed by 18 zeros. Can anyone do that? No, ma'am. What are you talking about? No, we cannot do that, right?
Nirmay said that 18 zeros are there.
18 zeros are there.
19 zeros. Yeah, we have a lot of answers.
All right. Yes, fine. So we'll be having these much atoms in 1 single grain of the sugar or salt particle. So think about human body. If this 1 particle will be having this much atoms, what about our human body? How much atoms will be constituting us? Just imagine that.
Can you show the previous slide?
Previous slide, definitely yes. Here we go. So that's it. So every matter is consisting of particles, the tiny particles, and we can call that particles as atoms and molecules. Now time for the experiment. Shall we do this? Here we have a glass of water, right? Glass of water is there. Can you see that? Hold it in your hands. Hold it. Yes. Pour the glass of water and you will be having that. And I am taking some salt. Okay. Do you have the salt with you, right? Let's do it. The glass of water and the salt. Shall we do it? Everyone keep ready with your equipments. Chemistry class, science, we have to do the experiments. Yes, here we have the salt and the water. Right? Let's make something. Now slowly add those particles inside the water and clearly observe it, okay? Clearly observe while you're adding it. While you're adding it, just clearly observe it. Okay, you have the particles over there. So much, it's very cute, right? Now mix it, and mix it. Yes, until it dissolves, just mix it. Yes. Did I mix it? Everyone is busy doing something. Their parents will be like, are we teaching some kitchen programs over here or not? No, this is the chemistry class, right?
Everyone is doing it.
Everyone is doing it. And it is
Some of them
completely
are
mixed.
not doing it.
And it's completely mixed over here. Can you see that? You can see that, right? Now, where does this particles gone? Where does this particles gone? We had put some sugar or salt in it. I'm not watching any particles over there. Can you see any particles in your glass? Can you see any particles in your glass?
It dissolved, ma'am.
It dissolved. It dissolved. That means our particles broke down. Our sugar, one particle, we weighed it, right? The particle was there in our hand. When we mixed it in the water, the sugar particle just got dissolved. It broken down into smaller particles. It explains that the sugar particles or any other particles will be having tiny millions and millions of particles in it. When we dissolve it, they break down and disappears. These particles, we cannot see it anymore because these particles are very much tinier in nature or very small in nature, and they break down into simpler and simpler particles. This explains that the particles or the matter is consisting of tiny particles. Now let's keep it aside. We'll do the experiments, okay? We'll continue that. Now keep it aside. So the animation. Now let's check out. This experiment was not enough, so let's check out an animation. Yes, a camera food. Let's check out an animation. Here we go. We have the beakers. Watch carefully, okay? Watch carefully. Now, we have to take the distilled water, as you can see over here, and the beakers, and suppose there we have the test tube and KMnO4. What is KMnO4? Yes, what is KMnO4? Let me know, what is KMnO4 exactly? What is KMnO4? Very good. KMnO4 is nothing but potassium permanganate. Potassium permanganate is nothing but KMnO4. You will study that in the higher classes. Okay, no worries. Now we have KMnO4, which are the crystals. Okay, KMnO4 are the small crystal like sugar, but it will be having a purple color. Okay, they are the crystals. KMnO4 are the purple colored crystals. Okay, they are the purple colored crystals. What is that? The first one, Amrish, right?
Rishikesh.
Rishikesh. Rishikesh is laughing so much. What is that, Rishikesh?
Rishikesh was late.
Rishikesh was late?
Yes.
Why Rishikesh?
Because I have karate class.
You had karate class instead of chemistry class. You were attending karate class?
Because I am late, yeah.
Because I'm late, because I went for karate class.
Yes.
Okay, fine. So you missed out so many experiments. Rishikesh, you missed out everything. Here we go, KMnO4. And now let's play the animation. Let's take a few crystals. First of all, let's take some water inside the beaker. Okay, let's take some water inside a beaker. And yes, sir, please. Let's take some crystals of KMnO4 and put it inside the beaker. Watch carefully, okay? And let's mix it. And we got the beautiful purple color solution. Over there. Can you see that? Yes. So this even small grains of KMnO4, we had put only few grains of KMnO4, right? Even though it colored the whole solution. Now let's continue the experiment. Yes, sir. Continue the experiment. Let's take another 90 ml. Okay, wait there. Let's take a 90 ml of distilled water again in this beaker, and let's take the rest of the 10 ml to make out 100. Let's take 90 ml of distilled water and 10 ml of that solution that we have prepared. Again, we mixed that solution with the pure water, clear pure water. Now again, the color persists. Okay, let's continue this. Again, let's take 90 ml of distilled water inside this beaker and let's take 10 ml of this solution, the second one, and let's pour into this. Again, we got the color. Again, we got the color. Let's continue this. Again, 90 ml of water and 10 ml of this solution to make it out 100. Again, we got the color. And finally, we have one more beaker. Let's pour the water. 10 ml of this solution. Again, we got the color. We got the color. The color is persisting in all the 5 beakers. What did you observe over here? Let's unmute someone, ma'am.
Okay, let's ask
What did you observe in this particular experiment?
Neha. Yes, Neha.
Neha.
We observe that the color is changing, but as you're getting new solutions, the color is becoming lighter because you're using the used one, right?
Yes.
And you're mixing it with a pure solution.
Yes, that's it. So here, let me explain it again. So here we have the crystals of KMnO4. When I mixed this crystals of KMnO4 in 100 ml of water in the first beaker, it got colored. It got colored, right? You can see the color of this first beaker. And when I took 10 ml from that beaker and poured into the second one, the color was persisting. That is just because the purple color solution will be having a lot of particles of KMnO4. We have studied that even a small grain of sugar particle or the salt particle will be having that much particles in it. So when I dissolve this, it is the same experiment that we done right now with the glass and the spoon and the sugar. It is the same experiment. The one that we are taking over here is just KMnO4. The experiment is one and the same. So here, the particles, the grains, the small particles or the grains of the KMnO4 just got dissolved in the solution. In the water, they got dissolved. And when they dissolve, they will dissociate or degrade into small particles in it. So we will be having millions and millions and millions of particles inside one grain of KMnO4. So we got the beautiful color. So when we took 10 ml out from this beaker, that 10 ml also will be having millions and millions of particles of KMnO4. That is exactly why we are getting color in the second beaker. And again, we took 10 ml out from this beaker, and that 10 ml also have millions of particles of KMnO4 crystals. That is why they made this beaker colorful. And again, we took 10 ml of this solution. Again, we poured into this. Again, we can see the color just because there is millions of particles of KMnO4 still in the solution. Again, we took 10 ml. Again, the color persists. That means a single grains of KMnO4 will be having this much particles, this much tiny particles. And that is why we are getting color in this large solutions. Okay, in this mass solutions, we are getting color by adding small grains of this KMnO4. A little grains of KMnO4 can color this much solution or this much water. What does this indicate now? Let's unmute someone, ma'am.
Okay.
What does this experiment indicates now?
Let's ask Durgesh.
Durgesh, what does this exact experiment indicates? Durgesh. Durgesh, no response.
Durgesh.
Can you please unmute Durgesh?
You will get a
Ah,
notification.
yes. Very good.
Can
Yes, I can hear you, Durgesh. Come on.
Ma'am,
What's the result of this experiment? Durgesh.
Yes.
Durgesh.
ma'am, can you hear me?
Yes, I can hear you, Durgesh. What is indicated by this experiment, Durgesh? What is the final observation? Durgesh have some network trouble, I guess, right?
I don't know, maybe. Yes. Okay,
Yes.
let's ask.
Okay, let's unmute someone else, man.
Let's ask Christo.
Christo. Yes, Christo. Christo.
Yes.
Ma'am, this shows that even a single drop of potassium permanganate can change the color of the experiment.
What does that indicate?
Even a single drop of potassium permanganate can change the color of the beaker.
Change the color. What is the core point? Why are they changing color?
And because of the low level of the potassium permanganate.
No. They will be having a lots of particles in it, right? That is the exact reason that you have to give. So since the small grains of KMNO4 is changing the color of these water, that it clearly indicates that the KMNO4 will be having a small grain of particle, will be having a tiny millions and millions and trillions of the particles inside them. Okay, those particles are dissolving. That's why we cannot see the particles with our naked eyes. But still they are giving out the color. Still they are giving out the color, which clearly indicates that they are consisting of tiny, tiny millions of particles. Okay, is that clear? That is a physical property of matter. So,
Teacher, will you please show the previous slide?
previous slide left, definitely yes. So here we go. Yes, sir, you can move it. The previous slide, here we go. So this is the first point that you have to remember when we talk about the particles of matter. Every matter is consisting of tiny particles. We can call them as atoms or molecules. These particles of matter are very tiny in nature. We cannot see them with our naked eyes. And the statement, you have to make sure that you study this right now. Did everyone study this? Yes. Done? Is that done? Is that clear so far? Give me a thumbs up. A double thumbs up if so much clear so far. Shall we move towards the next topic, which is nothing but the characteristics of particles of matter? Shall we do that? Which is way more interesting than this. Yes, here we go. Characteristics of particles of matter. Make this heading in your notebook. Yes, write down the heading. Write down the heading. Characteristics of particles of matter, and we have three characteristics. Three characteristics. Okay, before that we have studied that the particles of matter are the building blocks and which is very tiny in nature. Matter is consisting of tiny particles. Don't ever forget this. Now we have to study the characteristics of particles of matter. Now what do you mean by characteristic? What do you mean by characteristic? What do you mean by characteristic right now?
Let's ask someone. Okay.
What does
let's
mean
ask,
by characteristic? Generally talking. Not
Yes,
about the
Sanjay.
particles. Generally, what are characteristics? What are the characteristics? Yes, Sanjit.
Yes, ma'am, like features, ma'am.
Features. Okay, features. Very good. So I'm talking about myself. What are my characteristics? I have short hair and I have two eyes, one nose, and the lips and the teeth. So those are my characteristic feature of mine, right? So what are the characteristic feature of yours? All will be having two eyes, nose, 2 ears, and one mouth, like that, right? Yes. So all will be having their own characteristic features. Likewise, the particles of matter will be having their own characteristic features. Okay, now we are going to learn about that. Are you all ready? Are you all ready for that? Again, don't forget to give me the thumbs ups. I'm expecting so much from you. Very good, very good. So here we go, the first one. Particles of matter have space between them. Is that true? Do they have space between them? The particles. Okay, the pen will be consisting of millions of particles. Now I'm telling like the particles will be having space in between them. Is that true? Is that true? Let's check it out. Let's check it out. Again, we have the glass of water. Let's take this glass of water again. Again, we have the glass of water, right? Take it. Take it. Take the glass of water. Okay. Amrish is like, why are you holding a glass right now, ma'am? I missed out everything. Right, Amrish? Yes, so hold the water in your hand. Hold it, hold it. Everyone have the glass of water now. Now, clearly observe. Do you have the spoon with you, right? Do you have the spoon with you? Before that, let's check the level of this water. Check the level of this water. Check the level of this water, okay? Check the level of this water. Everyone, clearly observe. A clean observation is the must thing that we chemistry students want.
Teacher, sorry. Eric Joy, his, for more time, his hand raising.
Okay, Eric, what is it?
But we can't see his video.
Okay, fine. That's perfectly fine. What is it, Eric?
I was keeping my hand raised for a long time.
Yes,
now.
yes.
I'm really sorry I didn't saw that.
One fact about matter, and I had one doubt.
Yes.
The one fact about matter is matter cannot be destroyed nor created. And if matter is, since matter is made up of atoms and molecules, can't we see these said atoms with a microscope?
Yes, definitely we can see them with a microscope. I have made clear that we cannot see them with our naked eyes. We cannot see them with our naked eyes. By using ultra microscopes and electron microscope, we can see those particles. Definitely we can see them.
Okay. And another, can I say
matter
one
can neither be created nor be destroyed.
Matter?
Was that your doubt?
Yeah. That was my doubt. So can I say another characteristic of particles of matter?
Can you wait? Okay, tell me now. Anyway, we'll discuss that, right? Yes.
The particles of matter attract each other.
Very good, very good. We'll discuss that detailedly, okay? Now, that's it. Here we go. The particles of matter have space between them. Let's check it out. So here we have the glass, everyone. Did you observe the level of this water, everyone? Yes, you did. Now, put a spoon inside this water. Put a spoon inside your water. Did you do that? Now, check the level of this water. What did you observe? Ma'am, admit someone. What did you observe while you put the spoon inside your glass? What did you observe?
Let's ask Abhinav.
Abhinav, yes Abhinav.
I can't see his glass, his spoon.
Abhinav, where's the spoon and glass?
Ma'am, sorry.
Here it is. So,
Actually, I didn't take the spoon, I just taken.
okay, you don't have the spoon. Okay, that's fine, that's fine. So, what do you think we'll observe if I put spoon inside this glass? What will be the level of this water? Will it increase or decrease? Everyone, comment it. What about the water level? What about the water level? Everyone, comment it. That's it. The water level is just increased a bit, right? The water level is just increased a bit. Just because this spoon wants some space to occupy, right? This spoon wants some space to occupy, right? So the water level just got increased. Now what if I put a finger inside this water? Just put your finger inside this water and check the level of water. Check the level of water. Just put your finger inside this water and check the level of water now. What did you observe? What did you observe? Let me know. What did you observe?
Yes, everyone is saying it increased.
Again, it increased because these things are matter. The spoon, the finger that I'm having, everything is matter, and the matter occupies space. Am I right? The matter occupies the space. Now, clearly observe the level of water. Okay, this should be a clean observation. And now, let's set the salt. Where is it? So, it should be a clear observation. Okay, clear observation. Mark the level of the water. Now let's take some salt. Take some salt again. Quick. Quickly take some salt. Quickly take some salt. And now dissolve it. Dissolve it. Dissolve it. Again dissolve it. Okay. Clear until you get the clear water. That's enough, sir. I'm done with that. Till you get the clear solution, just mix it. Okay. Mix it, mix it, mix it. See? So it is so much dissolved now. Right? It is dissolved. It is dissolved now. So now check the level of water. Now check the level of water. Is it same or increased or decreased? Now check the level of water. Is it increased, decreased or just the same? Let me know, let me know. Let me know. What about the level of water inside the glass? And do we have the answers, ma'am? The level of water increased for some?
Some of them are saying it's same. Some of them are saying it's increased. Yes, same. Yes.
But the thing is, the level of water will not change. It is one and the same. I don't know if you had a clear observation. The level of water just remains the same. It is not increased. So, let me ask a question now. When we put finger inside the glass or spoon inside the glass, the level of water just increased. Now, but the sugar particles, when I added the sugar particles, the level of water is just the same. Why? It's just the same. Why? Is it because our sugar particle is not the matter or it is not taking up any space over there? Is it like that? Is it like that? Let's unmute someone, ma'am.
Okay. Yes, Alfie.
It's getting dissolved with the water.
It is getting dissolved with water, yes. So if I put some sand over there, definitely the water level will increase, right?
Yes.
Now, if I added sugar particles or salt particles inside the glass, it is not increasing. I want the exact reason for that. I want the exact reason. Why is that happening? Why is that happening? Think about it. Stick on to the question and think about it. Stick on to the question. Why? Why this sugar particles is not increasing the level of water? Isn't that sugar particles not a matter or taking up the space? Why exactly? Now,
So
think about that. Think about that. Think about that. Now, meanwhile, I'm reminding you again that we have a YouTube live over there. Did you share the link? Yes, I'm just reminding that. Okay, fine. Let's move towards our portion. Yes, the first one, ma'am. Neha, right?
Yes.
Neha, I saw you, Neha. You did very well. You were doing all the experiments.
She is
it
so
was
much curious.
It is a bit impressive. Very good. Yes, Neha.
Thank you, ma'am. Yeah, I wanted to answer your question.
Yes.
Because like when we add sand, it does not break down and it dissolves to the water. Instead, it is like a sediment and it just settles down below the water. And it occupies space, which makes the water rise.
Very
But if
good.
you
That's it.
salt
What about
and,
the sugar and sugar?
Yeah, but when you take salt and sugar, it will make a chemical change. Like it will make a new substance out of it. You know, like it will break down and it will be part of the water.
Definitely it will break down, but there is no new substance produced over there, okay? That's the wrong statement.
Oh, okay.
No new products are formed over there. So dissolving sugar or salt inside the water is just a physical properties. Physical change, there is no chemical change occurring over there. So you have to keep that in mind.
Anaka is also hand raising. Let's ask her. also.
Yes, okay. Who's that?
Yes,
Anaka. No, Anaka. Yes, I can.
Ma'am, the level of the water did not increase because the particles of the sugar filled up the spaces between the particles of the water.
That's it. That's the exact reason. Sir, now the animation. Let's check out what exactly is there inside the cup of water. So the animation. Mm, the first one, which was outside the pen. Here we go. Yes, sir. Here we go, the glass of water that we are holding right now. There's a glass of water that we are holding right now. Now let's check it out. What is exactly there inside the glass? Let's magnify it, okay? Let's just magnify it. Yes, sir, do it. Magnify the glass. Zoom it. Here we go. So can you see the water particles? So what is water? So a bit before, forward, backward. Here, stop it. No. A bit after this. Yes, here we go. Here we go. So these are the water particles. You can see that, right? What is water? Water is nothing but H2O. Two hydrogen linked with oxygen. So these are the water molecules inside this glass of water. Even if you cannot see these particles, it is really there. So water molecules, okay. So you can see the separate water molecules over there, right? And they are moving around. They are moving around. And as you can notice, there are a lot of space between them. Can you notice that? The water particles or the water molecules will be having a lot of space between them. They have the space between them. So what will happen if we add sugar particles in it? What is exactly happening over there? Let's do it. Sir, play it. Now our sugar particles are coming right over there. Can you see the sugar particles? And they are taking up the space between the water particles. They are taking up the space between the water particles and they are moving around with the water molecules. So as you can see, the water will be consisting of these water molecules and these molecules or the atoms will be having space between them. And these sugar particles, they are very tiny, right? When we told that the particles of sugar will break down, they will be split into smaller and smaller particles, and these spaces are most and importantly occupied by these particles. Okay, so it is enough to occupy this particles. It is very much enough for this particle to occupy the space. Okay, so here we go. So what did we observe over here? Let's unmute someone, ma'am. What did we observe over here?
Okay, let's ask Nita.
Nita, what did you understand?
Nital is mine.
Nital, what did you observe or what did you understood from this animation? Or the experiment that we done in our hand? The live experiment? What was the thing that you observed?
They have less atoms compared to our fingers and spoon. That's why it is not rising. The water level is not rising up. This sugar is getting this the water.
Yes, so all you have to do is just imagine. Close your eyes and imagine the particles of water. The particles of water. And someone is closing their eyes. I'm so impressed. They are doing what I'm saying right now.
Yes.
I like that. Thank you so much. Thank you so much for doing that. So someone really closed their eyes and they are imagining. So here we go. The water particles, imagine right now the particles inside the glass and they will be having space in between that and that spaces are occupied by these sugar particles. So they doesn't want any other space. So the level of water is just kept the same. They are not increasing just because the particle space over here is so much enough for the small tiny particles. So the thing that we observed over here, the characteristic of the particle that we are observing right here is the particles of matter have space between them. That's the only characteristic that we are showing over here. Okay, did you got it? The particles of matter will be having space between them. It is clear now, right? Am I right? Is this concept clear for everyone? Let me know. Let me know. Give me a double thumbs up. Give me a thumbs up if you
Guys
understood
already giving me the
everything.
double thumbs ups. Yes, everyone.
They are giving me thumbs up without even telling that. So this is what is exactly happening. So you don't have to by heart anymore. Just understand the concepts along with the animations and with our live experiments. Understand the concepts. Not just by hearting is not a good thing, right? You will lose the memory if you just keep on by hearting everything. So don't do that. Understand the concepts. So what did we understand over here? The particles of matter have space between them. They have the space between them. Okay, they have the space between them. And the next thing, we have only 10 minutes. Yeah, we can study one more characteristic.
Already Sanjit is reminding that's quiz time.
Quiz
Like
time.
that.
Okay, 5 more minutes. Okay, 5 more minutes. Let's continue the class. Yes, here we go. The particles of matter are continuously moving around. You have seen that water particles, right? Have you seen the water particles? The water particles. The water particles. The animation that you just played right now. Let's check it out. Here we go. The particles of matter. Play it, sir. Here we go. The particles are moving. Can you see that? Just keep on playing that, sir. The particles are moving around. They are moving around, as you can see. So what is the next second characteristic? What is the second characteristic? Particles of matter are continuously moving. Even though we cannot see, they are moving, but actually they are moving around like this. Okay, the particles of matter are continuously moving. They are continuously moving. This is the second characteristic. This is the second characteristic that you have right now. Yes, sir, you can remove it. So, what is the second observation? Particles of matter are continuously moving. Sir, the next animation. The particles of matter are continuously moving. So, we want the experimental proof again. Will not believe. If we just written in the words, I will not believe it. But we want the experimental proof. Let's do it. Yes, sir. The ink. Let's take one beaker. Okay. Listen carefully and watch carefully. Let's take one beaker and we fill that beaker with the water. Okay, let's fill the beaker with the water, and if you have the equipments, you can do the experiment with you. Okay, if you have the experiment, no, don't do that. Don't spoil your glasses. You might be getting scolded from your parents. Okay, so don't do that. Okay, let's take the ink. Okay, so play it. Let's take the ink and let's pour it to the water. Let's check what do we observe over here. Let's pour some ink. Can you see that? We are pouring the ink. What did you observe? Okay, if you want, you can do this, okay? But never blame me if we get scolded from your parents. Don't blame me, okay? Because my chemistry teacher told so I'm doing it. So never blame me, okay? What has happened over here? What has happened over here? What just happened? Ma'am, unmute someone.
Okay.
What did you observe in this experiment?
Actually,
You can play it again, sir.
Wait, ma'am.
Yes. Yes.
Ishan.
Ishan.
Is, actually, long time he is hand raising.
Hand raised for the long time. Yes.
Yes, Ishan.
Ishan. Yes, Ishan. Do you have any concern? Yes, definitely ask me.
Ma'am, I wanted to know if these particles of matter attract each other.
Yes,
They're constantly moving, but do they attract each other?
That's the third characteristic. We'll discuss that. Okay. Right after this characteristic, I will discuss that. Okay.
Okay.
So first, let's understand how they are moving around. So this is the first experiment that we have right here. So the ink. ink started from one point. So can you repeat the animation again? So can you just replay that? So this ink started from one point on the surface of this water level. So how did this ink spread out all of a sudden? How did this spreading out over there? What is exactly happening? Are they moving around? What is exactly happening over there? Let's wait and watch the second animation. Okay, let's keep it aside. And let's go for the second experiment. Yes, sir. Remove and go for the second one. It's just nothing but incense stick. So here we have the next experiment. Okay, what is this? What is this right over here in the corner of your house? You all are familiar with this, right? What can you call this in your language? It is incense stick. Incense stick in English. So what is in your language? Agapati. Or in Malayalam it is Chandanatiri. And what is the other things that you can call out for this? Agapati, right? Agapati. We always usually say that. Agapati. Incense stick. So let's play the animation, sir. So if we just light this incense stick in one corner of our house, okay, the smell will reach out our nose even if we are far away from this corner, right? Even if we are far away from this corner, we can reach out that smell, right? The smoke is going around, as you can see. Why? Again the question, why? Why are they moving around? We can smell that this perfume or the aroma of that incense stick even after we are far away from this. So why is that? Why is the aroma is reaching out our nose even though we are far away? Why? Again the question, why?
Okay, let's ask.
No, ma'am. We have some more animations. Okay.
Okay.
To the third animation. It's a diffusion of gas. To the third animation. Here, our mom is cooking something and we can get the beautiful smell of that cooking, right? Have you ever experienced that? What kind of question is that, ma'am? So, can you see that? The smell, we can feel that smell of the cooking things and we can get an idea what she is cooking right over there, right? If she is cooking some biryani, we will get that beautiful smell. So I'm not going to explain that again because you guys are fasting. So I'm not going to do that. So why are they reaching out in our nose? Just because the particles, as you can see in this image, the particles are moving around. So play the animation. The particles over here are continuously in a motion. The particles are moving around and they move and diffuse into the air and they will reach out to our nose right after there. So what is the observation here? The particles of matter are continuously moving. And the first experiment, ink. Now you're going to tell me what exactly does that ink do. Yes, ma'am, unmute someone.
Okay. Yes, Ruben.
Ruben. Yes, Ruben. Mehrub, right?
Yes, ma'am.
No,
Mehrub, right?
Ruben.
Ruben. What has exactly happened in the first experiment? When we dropped ink in the water, they evenly spread out. Even though it took some time, but they spread out in the water. What exactly happened there? What is the property explains over there?
Ma'am, the experiment when the ink when the water dissolved.
Ink dissolved. Why? The ink was moving inside the water, right? They moved and spread out throughout the water. What characteristic of particle explains in that experiment? Come on. You can. The particles are moving, right?
Yes, ma'am. The matter.
Matter is there and the particles of the matter are continuously moving around. If they move around, they will spread out evenly. That is what happened in the first experiment. The particles of matter are in a continuous motion. What about the second experiment of agabadi or incense stick?
Ma'am, like the
the smoke of the agpati was it was how do I say, right? It was I don't have the word for it.
Moving around.
Yeah, moving around. Yes, ma'am. Like it was moving around with matter, so it's air.
That's it. Okay,
It's
okay,
moving
fine,
around.
fine. That's it. Because the particles of matter are in a continuous motion. They are evenly moving around us, right? That's why we are getting the smell, even though we are far away from that agarbatti. We are getting that smell. We are getting that aroma just because the particles are moving around. The particles are moving around in the air, and we are getting the smell right after there. And again, the cooking. Again, example for this. The particles of matter are in continuous motion. That is the second
Yes,
characteristic.
ma'am.
Is everything clear? Is
Yes,
everything
ma'am.
clear for you?
Yes, ma'am.
Yes, very good.
So matter will go it'll go. Matter will go through air, fire, water, and all, right?
Yes, everything is water, right? Everything is water.
Yes, ma'am.
Matter. Everything is. I'm sorry. Everything is matter, and matter can go through anything. So don't
Okay.
go through that brick, okay? Don't hit that brick over there just because ma'am said we can pass through anything. Don't ever do that, okay? It's not like that. We'll explain that in the next class because we have one more property called. They have said that the particles attracts each other. We'll discuss that. So here we go. That's it. That's the second characteristic, and we are out of time.
Teacher, we have a birthday girl, Aradhana.
Really?
Yes.
Yes, can you please unmute her?
Aradhana.
Aradhana, we have a birthday girl. Now she is telling that. You could have told that in the beginning, right?
Yes, Aradhana.
Yes, Aradhana. Where is she? Aradhana, happy birthday. Let's sing a song for her, ma'am. Yes, ma'am.
Eh?
Let's sing a song for her.
Okay.
Everyone, sing along with me, okay? It's Aradhana's birthday over here, the birthday girl. So let's sing along with me, okay? Happy birthday to you. Happy birthday to you. Happy birthday to you, Aradhana. Happy birthday to you. Yay! Happy birthday, Aradhana. How was your day, Aradhana? It was good.
Yes.
Only good? Yeah. How was the celebrations then?
It's already done.
It's already done in the late night, I guess. Right? Very good. I'm wishing you again a happy birthday. And live long and be happy always, okay? Keep smiling like that. Alright. So that's all about today's session. What are the things that we have discussed in the session? What are things that we have already discussed in the session? We discussed what is a matter, and also we discussed what are the states of matter, and also nature of the matter and characteristics of particles of matter. We are not done with that yet. We have one more characteristic and we'll discuss that in the next session. Is everything clear so far? Give me a thumbs up so that we can move to the exam part. Give me a thumbs up. Quick thumbs ups. And do anyone have any doubts? No, ma'am. Everything is so clear, right?
I think Advait.
No. Thumbs ups are here. So let's move towards our exam online test. Here we go. So, do we have any new students? I forgot to ask that in the beginning itself. So, do we have the new students who's watching me for the first time? And here we have a new student. What about them?
Yes, we have.
We had a lot of new students, right? You can just raise your hand if you were a new student.
Yeah, we have.
We had so many. I literally
lot of them.
Lot of them. I literally forget to welcome to the class. Again, at the end of the session, I'm again welcoming you to our family, okay? Welcome to your 90 plus family. Most welcome. So, how was the class? How was your experiment? How's the experiments? How's the animation? And what about your experience regarding the classes? Was it good? Was everything else understandable? Clear? You can let me know in the comment section. Everyone is giving me thumbs up.
Yes.
Yes.
Actually, all of them are eagerly waiting for the Google form.
Eagerly waiting for the Google Forms.
Yes.
Yeah, again, I'm welcoming you to the session. Not to the session. The session is just ending. To the family of 90 plus. Okay, yes. Here we go with the link. And for the new students, for your kind knowledge, we will provide the link for the Google form. And you just have to attend the exam. Just press the link and fill the name and roll number. And you can pick the options over there. And press the submit button. Here we go. In 3, 2, and 1. Yes. The first question. The quantity of matter present in an object is called as weight, gram, mass, and density. Yes. And the second one. Particles of matter are tiny, small, large, and none of the above. The third question. Panchatattva of life. Air, God, water, mother and father. Or air, fire, earth, sky and water. Air, God, water, soil and crop. And the last one. Air, God, water, yield and money. The funny options, right? Mother and father it seems. Alright, so the next one. When potassium permanganate dissolves in water, shows red color, blue color, violet color and orange color. Pick the right option. And the final and last one. Particles are moving in the bottom of the glass due to, I haven't taught this yet, but if you know the answer, you can just pick the options, okay? I have not taught this yet. So it is dilution, dissolution, kinetic energy and potential energy. Yes, ma'am, you got the right answer. Yes, that's it. Done with that? Give me a thumbs up. Give me a thumbs up. Sharon is so much happy, I think. She got 10 out of 10, I guess. Right, Sharon?
Yes.
Yes, Sharon is so much happy. She is celebrating by her own.
Yeah, Benjamin, you should submit that form.
Yes. Done with that, right? Give me a thumbs up. Give me a thumbs up.
So many
Let's
random
discuss.
text, ma'am.
Not done yet. I'll give you one more minute. The time is already over. Yes. Done. Let's discuss the questions. And you're going to notify the answer by using your fingers. Will you do that? Will you do that for me? Let me know the answers by using your fingers, whether it's the first option, second option, third option, or the fourth option. Yes, will you do that? Here we go with the first question. The quantity of matter present in an object is called as what? Very good. Everyone is giving me the third option. Definitely yes, it is called as the mass. So, what is matter? Matter will be having a certain mass in it. So, mass is the right option. So, here we go with the second one. Particles of matter are, I can see everyone's reaction. Okay, keep that in mind. Yes, that's it. They are very tiny in nature. Panchatattva of life. We are provided with so much funny options. And which is the right option? Father and mother, right?
No.
Father and mother is the 5 basic elements. No, never, ma'am. It's not like that. Air, fire, earth, sky and water are the 5 basic elements called as Panchatattva. Very good. Here we go. When potassium permanganate dissolves in water, shows which color? Yes, definitely it is violet in color. We have saw the beautiful experiment over there. So it was violet in color. And the last question. Wait a second. Not there yet. Yeah, we have the beautiful transitions too. Here we go with the last
Just for the
question.
sake of showing that transition, you changed the slide, right?
It's not like that, man. Particles are moving in the bottom of the glass due to... Oh, without even studying that, you won't know the answer.
10 out of 10.
Very good. It is nothing but kinetic energy. So if they want to move around, they must have the kinetic energy. I will discuss that in the next session. No worries, okay? With the beautiful animations, we'll do that in the next session. And here we go with the transitions. And that's it. Thank you so much. Someone is so happily moving around there. Thank you so much for watching to me, and I hope every concept was so clear for you. And we had a YouTube session, and the ones who were watching the YouTube, I think that session was so useful. And again, thank you so much for listening to me, to have that patience. Thank you so much. And I'll meet you with the upcoming topics in the next session. Until then, take care and bye-bye. Good night, everyone.